Hello students, this is Sandeep sir here. In this video, I am going to explain resistors in series. Okay, the derivations I will do, and I will explain what are the main points we should remember while solving the problems in resistors in series. Okay, I am considering there are three resistors. Okay, let's say this is resistor R1 is there connected in series with another resistor R2. Okay, connected in series with another resistors R3. Okay, all are connected to a battery of V volt. Okay, so this battery will give a current I, let's say. See here, I current will pass through R1, R2, R3. What is the common in resistors in series? I is same, children. First of all, I is same. First thing you should remember is I is same. Current is same in the series circuit. Okay. Next point, what you have to remember? See, whenever I passes through R1, children, so there is a potential drop across this, that is V1. Similarly, when I passes through R2, there is a potential drop across this V2. Similarly, when I passes through R3, there is a potential drop across this V3. What happens then in this, whatever the voltage we are providing in the series circuit, that divides between R1, R2, and R3. So what is happening here? That the total potential which is applied is equal to V1 plus V2 plus V3. Is it clear? These 2 points you should remember. In the series circuit, current is same because you see whatever the current is entering from here, same current, same path is followed, right? So the current is same. Now I want to derive. Okay, what is the R equivalent? Means series resistance formula. RS is equal to R1 plus R2 plus R3. How we are going to derive this? Okay, let's see. Okay, so please watch the video till the end. Okay. Okay. Now I'm starting, children. See, whenever I current passes through R1, okay, so what is the potential drop? We can write a potential drop across R1, across R1. What is the potential drop? V1. V1. What is the formula from Ohm's law? We can write current into resistance. Current is I, resistance is R1. Let's see question 1. Similarly, potential drop across R2, children. Okay, whenever I current passes through R2, so there is a potential drop, that is V2. V2 is nothing but I into R2. Assume this is equation 2. Similarly, potential drop across R3. Whenever I current passes through R3, there is a potential drop, that is V3. V3 is nothing but I into R3, children. Assume this equation 3. Now what I am doing, instead of these three resistors, I am taking one equivalent resistor, okay, whose value is Rs, connected to the same battery of V volt. As battery is same, so current also will be same. We can write, children, whenever I current passes through Rs, there is a potential drop across Rs. Okay, what is V? V is nothing but I into Rs. Do you agree with me? So it's okay. This diagram, I'll just draw it down. Okay, let's see once again. Okay, potential drop across Rs. That is V. V is equal to I into Rs. There was a resistor of Rs value. Okay, yes or no? And V voltage battery was connected. Okay, so current was I. So same I current pass through this, right? So I into Rs will give you the V voltage, right? Now what I'm doing, let's say this, as you know that in the circuit, series circuit, total potential divides, right? So V is equal to what? V1 plus V2 plus V3. Now substitute the value of V1, V2, V3, V4. Okay, not V4, V from equation 1 to 4 in this equation. Let's say this is equation A. So we can write using, using equation 1 to 4 in equation A. In equation A. So what is V? V is nothing but I into Rs. You can write here. Substitute the value I into Rs. What is V1, children? From here, V1 is equal to I into R1 plus I into R2, that is V2, plus what is V3? I into R3. So we can write I into Rs is equal to I is common in all. So we can take I common. So R1 plus R2 plus R3. Is it clear? Okay. Now what we can do? I get cancelled right here. So we can write finally Rs, that is the resistance in series, is equal to R1 plus R2 plus R3. This derivation they may ask for 3 marks. Very, very important. You have to remember, children. Let's take one problem, children, here. Okay, I'm taking there are 3 resistors. Let's say this is 5 ohm resistor. Another is 10 ohm resistors. Another is 15 ohm resistors. Let's take it is connected to 60-volt battery. Okay, they may ask you what is the R equivalent of the circuit and what is the current passing through the circuit. Now, as we can see, these 3 resistors are connected in series, right? How it is series? One end is connected to one end of other. Okay, so that is Rs. You can find 5 plus 10 plus 15. So 15 plus 10, 25 plus 5. It is 30 ohm, children. Okay. Now, the circuit we can say this is like this. Rs is there, which is of 30 ohm connected to 60 volt, connected to 60 volt. So to get the current, apply the Ohm's law, V by Rs. So V is how much? 60 by 30. Cancel 0, 0, 2. So it is what? 2 ampere. Is it clear? I hope you understood these concepts of resistors and series. Okay. Please share with your friends, children, and subscribe the channel. Okay. Thank you, children.